Hello and welcome to yet another lecture on basic electrical engineering, paper code ESEE 101. Myself, Prathita Roy, Assistant Professor of Dr. Sudhir Chandra Institute of Technology and Sports Complex, Department of Electrical Engineering. Today, my topic is Arctic. Lesson objective. After end of this topic, students will able to understand the concept of earthing. Earthing. So the term that is called earthing, we all hear this term in our daily life, the earthing. So the earthing means whenever a current conducting material or current conducting metallic part of an electrical equipment comes in contact with a live conductor, it accumulates charges and the potential is developed across the metallic part. This is the basic conception that when a current conducting metallic part of an electrical equipment that come in contact with a live conductor means the current carrying conductor, that particular equipment that accumulate charges. In a result, as a result, a potential that is developed that across that metallic part. Once there is a physical contact of this metallic part with any part of the human body or any living creature, the accumulated charge that is tends to flow through the living body. So the living body will experience a shock that we have that we have told in our daily life that I am getting a shock from the electric circuit. So what does means? What are the basic phenomenon that works behind the shock? The term called shock. When a person gets shocked, what is happening behind that particular shock phenomenon? So that a person get shocked from an electric circuit. It is happened that say a metallic part of an electric equipment that come in contact with a live wire. Live wire means the wire that is carrying the current. So as a result, that particular metallic body or the metallic part that accumulated charge, and so a potential that is developed across that metallic part. So once that particular metallic part come in contact with a human body or living creature, there is a tendency of that charge to flow through that human body or the living body. So as a result, the human body or the living body that gets or experience a shock. So this is the general formation of shock and how a person gets shocked. That works behind the conception. However, if that metallic part that acquires the charges come in contact with the earth, earth means the ground, the potential of the ground. So when that living body that acquired shock or experience a shock, or in other words, we can say that it can acquires the charge when it come in contact with the earth or the ground. No static charge can accumulate in that metallic part, or we can say that there is no static charge that can accumulate in that metallic part, as it would flow to the earth. Means if there is an earthing is there, it will allow the accumulated charge, or it will give a way, or it will give a route for the charge that accumulated in the metallic part to flow through the ground or flow through the earth. This is the general process or the general conception that is working behind the formation of earthing. That means a metallic part which come in contact with a live wire, it accumulates the charge and develop a potential across that metallic part. So our main objective is to pass that accumulated charge, or it will allow a way or route for the accumulated charge to pass to the ground. Means it will come within the ground potential or the earth. This is the main conception that is working behind the concept of earthing. So the process of connecting the non-current carrying metallic part of electric equipment is called earthing. The process that I have told now of connecting the non-current carrying metallic part of the electric equipment is called the earthing. So this is the general conception that is working behind the earthing formation. Also, in case of electrical installation, the star point of a three-phase supply being called a neutral point, that, that is connected to the earth in the same fashion, so that the neutral point potential, if any, due to the unbalance in the three-phase system, to the three-phase supply is held at ground or earth potential, that is perfect zero potential. So if I see the neutral of a three-phase supply of a star connection, we will clearly see that a three-phase system having a star connection, that if I take the, remember that particular thing uh, by drawing a three-phase star connection. This is a three-phase star connection that I am drawing. So this is a phase A, phase B, and phase C. So we can write this is a star connection. RYB phase is there for a star connection, that we all know. So this is the point that we are considering, that is called the neutral point or N. So what I have told, that if that particular neutral point is connected with the help of a resistance to the ground, that is the conception of earthing, the ground potential, this one. So when that neutral point is connected to the ground with the help of a resistance, that means this is a three-phase supply that we have obtained for the RYB. So when that particular neutral is connected with the help of a resistance through the ground or earth potential, that means any unbalance that is occurred within the system, it will rotate through the neutral to the ground. That means this is the general conception of earthing that I have told. So for a star point, it is the in electrical installation. If the star point of the three-phase supply being called the neutral point, it is the neutral point of the three-phase supply, and it is connected to the earth in the same fashion. So the neutral potential, if may due to any unbalance in that three-phase system of the three-phase supply is a ground or earth potential, that is perfectly zero potential. So this is the general conception of a three-phase system for a star connection where a neutral is given and the neutral is directly connected to the ground potential or zero potential. If any unbalance is there within the system, that unbalance can be nullified with the help of that neutral or earthing conception. So this is called the perfect zero potential. And basically there are two types of earthing equipments requirements. The first one is the metallic non-current carrying part of the electric equipment or any electrical appliances is earthed due to the safety of the user. So the first one is the conception is the metallic non-current carrying part of the electrical equipment or any electrical appliance is earthed due to the safety of the user, and the second one is the earthing of neutral point. First one is taken the measurement of safety of the users, and second one is the earthing of the neutral point of the three-phase star supply so that the potential at the neutral point that will remain zero, that we have already seen. So the specification of earthing is standardized in all countries, and the basic feature of the earthing system are as follows. That is, there must be a separate earth continuity conductor or ECC, earth continuity conductor, which has the capability to allow flow of charges or currents so the earth to the earth. This conductor should have cross section more than 2.9 millimeter square and have low resistance so that the maximum permissible I square R loss is 8 watt. Usually, this resistance doesn't exist of 1 ohm. Usually, this resistance doesn't not exist to 1 ohm. So this is the first one, and second one, the first one, that is there must be a separate earth continuity conductor, the separate earth continuity conductor, that is ECC, which has a capability to allow flow of charge or current to the earth. This conductor should have a cross section more than 2.9 millimeter square and have low resistance so that the maximum permissible I square R loss is 8 watt. Usually the resistance not to exist 1 ohm. And the second one is the minimum distance of earthing electrode from the civil construction whose installations are being earthed should be 1.5 meter. So in electrical installation, there are two types of earthing system. One is known as pipe earthing and another is the plate earthing. So use of iron water pipe as earthing conductors is not allowed due to the safety reason. So first is the pipe earthing. So this is the general figure for the pipe earthing. This is the pipe earthing construction, and it is clear that galvanized perforated cast iron pipe, that is the minimum diameter of 38 millimeter and a length of 2 millimeter, is vertically placed in a 40 centimeter square earth pit that contain wet soil. So this is the general conception of pipe earthing, and the earth pit that is half filled with a mixture of wood, coal powder, sand, and salt. This is the conception of earth pit. So uh, it is vertically placed in a 40 centimeter square earth pit that contains wet soil. If the soil is rocky and dry, the pipe length that needs to be increased to 2.75 meter. If the soil is rocky and dry, the pipe length that is need to be increased to 2.75 meter. The perforation at the body of the pipe are 12 millimeter in diameter and are provided to allow the flow of water out of the pipe, and the depth of the pipe from ground level is 2.75 meter. The depth of the pipe from ground level is 2.75 meter. This is the general construction of pipe earthing. Again, followed by some of the construction are that the earth pit is filled up to a distance of 15 centimeter around the pipe with alternate layers of charcoal and salt up to a height of 2 to 3 meter. The earth pit that is filled up to a distance of 15 centimeter around the pipe with alternate layer, means the alternating in nature, the layer of charcoal and salt are in alternate manner, and its height is up to 2 to 3 meter. The charcoal and salt layers are provided for retention of moisture, thereby keeping the earth resistance to a low value. The height of each layer is 15 centimeter. The earthing pipe is connected to a galvanized iron or say GI pipe of 20 millimeter diameter. This GI pipe is connected to a funnel with a wire mesh at the top. So water that needs to be poured through the funnel at intervals of days to keep the soil wet in order to protect the earth pipe from mechanical damage. A concentrate layer is provided with cast iron, that is CI cover, at the ground level. This funnel is connected to a second GI pipe for connection of the wire of the earthware, for connection of the earthware. So this is the general pictorial view of pipe earthing diagram. It is clear that what I have discussed about the cast iron cover, that is the cast iron frame, and that is the cast iron cover that we have seen. And again, I have told about the funnel with mesh GI, that is the funnel with wire mesh, that is the funnel with wire mesh, and along with the clevel lock, and all the dimensions are given. This is called a 15 millimeter diameter GI, that is the galvanized iron pipe for earthware from electrical installation, and this is the earthware. So again, the concentration of the cement concentrate, that is cement concrete, that is this one, it is given by 1:2:4 ratio. Cement concrete And what I have told that a GI pipe of 20 millimeter diameter is seen here. And I have also told that there is a alternative layer of charcoal and salt, and height of each layer is 15 millimeter, that is clear. And that is the alternative. This is the 40 millimeter GI pipe that I have told. 40 millimeter GI pipe, and this is the charcoal and salt layer having a 15 millimeter, or say the 15 centimeter, we can say, the height of each layer. And it is the alternative way to give the charcoal and the salt layers, and its height is up to 2 to 3 meter, that is 200 to 300 millimeters, and the depth that I have already told, that is 5 to 6 meter deep from here to here. And this part is generally 200 to 300 millimeter, that is 2 to 3 meter height that we have told. And another is the holes of dia 12 millimeter in the GI pipe, that the holes that we have seen in a GI pipe, the hole that is provided. And this is the total dimensions are given for a pipe earthing. This is the general conception of pipe earthing. So this is the general conception of pipe earthing. The pipe earthing conception. So another part of our discussion is the plate earthing. So a copper plate is recommended in this method as earth electrode, that is instead of GI pipe. So in the previous discussion that we have seen, we are using the GI pipe. So instead of GI pipe, a copper plate that is recommended in this method as earth electrode instead of GI pipe that we have seen in our previous discussion, the GI pipe. So a copper plate is recommended in this method as earth electrode instead of GI pipe. However, for economic reason, sometimes the GI plate is also allowed instead of copper plate. The minimum dimension of the plate is such type of earthing system is 60 centimeter into 60 centimeter into 6.36 millimeter. This is the dimension, minimum dimension of the plate for this type of earthing system. The plate with its face vertical, the face is the vertical one, is placed at the depth of 4 meter in a pit. It is placed at the depth of 4 meter in a pit. The space around the earth plate is filled with alternate layers, each of 15 centimeter of charcoal and salt. A GI pipe that having a diameter of 12.7 millimeter is connected to the earth electrode, that is the plate. So a GI pipe having a diameter of 12.7 millimeter is connected to the earth electrode. So this is the pictorial view of plate earthing. So it is clear that it is a MS rod frame and CI cover. All the dimensions are given. That is, the cement concrete is 1:2:4. This is the GI pipe for watering of diameter 20 meter, and this is a 12 meter GI pipe for earth wearing pipe. If I extrapolate it, it will see this part, the copper or GI earthware, thimble, bolt and nuts, GI or copper plate. This one is detail of that particular section. So it is given that there is an charcoal and salt layer of 15 centimeter, and what I have told that a copper plate, that is the dimension of, if it is copper plate, Then the dimension is 60 centimeter into 60 centimeter into 3.188 millimeter. And for the GI plate, it will be 60 centimeter into 60 centimeter into 6.36 millimeter for GI plate. So this is the general plate earthing system. So we have seen the two types of earthing. One is the pipe earthing and another is the plate earthing. Thank you.